Okay, bro, this is the last part that we need to check on now, ne? So let's look at the proofs. So if they say to you, show that the following or the decimal is rational, right? Sometimes they won't tell you that it's a recurring decimal. They just say, show that then the following decimals are rational. And most of the time, this question is like around 4 marks. So you can't just use a calculator, ne? So like we did, we're gonna look at the decimals, right? So the key thing is to say, this is the first thing, this is the first step. Let x be equal to 0, 251. So because it continues, can write it as like this, right? And then I need to multiply this so that the decimal, so that I have this thing here, the numbers coming after the decimals to be the same. So if I multiply by, for example, let's say I multiply by 10, I'm going to move this. The answer is going to be 0, 2, not 0, 2. It's going to be 2, 51, then 251. So it's not really the same as this one here. So I can multiply it by 100. Let's see if I multiply it by 100. So it's gonna move 1, 2. So it's gonna be at 2, 5, 1, 2, 5, 1. So it's not really the same as this one here, 2, 5. So the key here is to multiply it by 1,000. So if I multiply it by 1,000, it's gonna move to the 1 there. So multiply it by 1,000. So it's 1,000 x. So this is equal to 251, 251, 251. So this thing is continuing. 251. It's continuing in that order. Then this is my first equation. This is my second equation. So I'm gonna say my second equation minus the second one. The second minus the first one. So you have 9,999x be equal to 251. Because of, if you can check something, this whole thing takes out this whole thing. They are the same. So, and then I just divide by 999, then 999. So therefore, my answer is 251 over 999. So this shows that the decimal is rational because of this is an integer and this is an integer. Let's get to the second one. Second one again, I need to have the same numbers after the decimals. They should be the same, recurring only after decimal. So I can, first thing, let x be equal to what is given. So you can see the numbers that are repeating is just 1 and 8, excluding 3. So the first thing I can do is to to have only the recurring decimals after the comma. So for me to get to 3, I can multiply by 10. So 10x. This is going to be what? 53, 1818. It's continuous, right? However, I cannot subtract these two because if I subtract them, this will not be eliminated because of this 3 here. So I can do what? Multiply again so that I can have only 181818 after the comma. So I can move 1, 2, right? So I need to multiply again by so 1, 2, 3. So I need to multiply by 1,000. So 1,000. So I'm gonna have 53, 5,300 and 18, 181818. Now I have achieved. This is 2, this is 1, this is 3. Now I have achieved 1818 after the comma, right? So I can simply do this. I can subtract the third one and the second one. Because of this, a 1818 is going to take out the 1818 there. Right, so I have 990 x being equal to, so I have 53, right? So gonna say 5,318 minus 53. So this is going to give me 5,265. Then I divide by 990. 990. So therefore the value of x equals to 5,265 over 990. That's the final answer. So it does show that these are rational. Then let's look at the last one. The last one is not really a lot that you can do. So we're going to say let x be equal to what is given, 0, 0.24. 24, 24. Right, it continues. So for me to have 24, I cannot multiply by 10, guys. If I multiply by 10, it only moves once. So I'll have 42, 42, 42, and that's not what I'm looking for. I want the order of repetition, 2, 4. So for me, to obtain that, I need to multiply by 100. Because of with 100, the comma is going to move twice, 1, 2. So multiplied by 100, so I'm going to have 24,24, 24, 24, continuing. So I say, this is my second one, this is my first one. I say the second one minus the first one. So I'm going to have 99x being equal to 24. Because of this thing here, and this thing here. Subtract then 0, 24 minus 0 is still 24. Then divided by 99, divided by 99. So the value of x is equals to 24 over 99. So it does show that this thing here, it's a rational number. So these are the questions you'll have to do.